Hello and welcome to another Stata video. My name is Stefan Eriksson, and in today's video we're going to be taking a look at two-way ANOVA. So let's get to it. But first, you may think, it sounds familiar. Well, that's because we already did a one-way ANOVA in our previous video, which you should check the link out from somewhere on the screen right now. But let's first establish what is a two-way ANOVA and when do you need it and what is it and all those things. So first here, you want to test whether there's a significant difference between the means in 3 or more groups, split by 2 factors in this case. If it was just split by 1 factor, then we're talking about a one-way ANOVA, and then we already learned the things in the previous video. And remember, if it's only between 2 groups, it basically comes down to a balancing test. So now we're going to do it split in 3 or more groups by 2 factors, right? So let's go through it step by step, and you hopefully see what I mean. I've already set my do file up. That means I've set my directory. And then, of course, we have a nice little data set, which we can web use here. And this will be the same data set, systolic, as we did in the previous video. So this should hopefully also be familiar. This is because this data set already has everything that we could possibly need. So, of course, let's fly the data in here. We have 58 patients, indeed, and we have 3 variables, drug, disease, and systolic. Last time, I believe we only did it on drug. Now we're going to use drug and disease on systolic to see the differences. Before you get into this here, you can always do a nice box plot, and you can box plot well over drug, but now we can also group it drug by disease, so you can get these subgroups in. We're going to do box plot in another video, but you can do things like that, which is quite nice. So you can just do, say, some summary statistics split across these groups. So these are things that you can easily do if you want to do it and want to know more about your data, and I'll always recommend doing so. But here we want to go in and use the ANOVA command to conduct a two-way ANOVA. You may remember last time we used a one-way command, and that's perfectly fine if you do a one-way ANOVA, but for two-way and more sophisticated ANOVA models or ANCOVA models, you would have to use the ANOVA command. But luckily, it's pretty much built up the same way. So of course, we're going to put up systolic, because that's the dependent variable. That's what we want to see what the difference is between this one and along the other groups. And let's first just start with a very simple way of doing this. So we do it for drug. And if I stop here, I basically have a one-way ANOVA, but we're just going to add the second one here. Hopefully I spelled it correctly, because that's my worst enemy here. So let's go in here and see what we're going to get out of it. And we're indeed going to see some very interesting things here. We get our model here, we get our number of observations, R squared, adjust R squared, and so forth. But what is really interesting here is these 2 lines. Because what we're looking at here is to see whether they are statistically different in the 2 groups. And what do we see here? By drug, indeed it is, at the 1% level. But we also see here for the disease, there's no statistical significant difference between the 2 groups. But what you may want to do here is that you may also want to test for an interaction term, so a fully interactive model. This is not, by the way. So we have not taken into account the interaction between drug and disease. And that we can do by adding the interaction term here. So I'm going to extend this, and then we're just going to say drug, and then use, maybe spell it correctly, drug, and then a hashtag here, and then disease. Okay, this hashtag here makes sure that we get an interaction between the 2. We've dealt with these interactions before in How to Make Dummies videos, which you can also look at. But basically what it does now, it adds in the interaction term between the 2, as we can see on the screen right now. And indeed, we also do not see any significant differences here. But we can, of course, also do this a little smarter, okay? So I will copy this one down again, new line, and then we can do 2 hashtags. This will give you a fully interactive model without having to write each individual one and the interaction term. So now we should get exactly the same if I wrote it correctly. And a quick click, and you see indeed the command coming up here, and you also see indeed I get exactly the same result. So this is a nice shorthand notation for how to do this. And you can use the same, of course, when you're doing your dummy variables, interaction terms, and these kind of things, which we've done in a previous video. So some of these things, they come back to us, which is quite nice. Now, just like in a one-way ANOVA, here we just see their statistically significant differences, right? We see they're different, at least according to drug. However, we don't know which groups are different or which drugs are different in here, whatever. So you can actually go and test which ones are. I will not say this is the way to do it. I'm just showing you how to do it, whether it makes sense or not. I'll leave that to you. But you can indeed do the PV mean command as we've seen before. So here we want to do it over systolic again. And now in the previous video, we would do it over and then write drug. But now, of course, we would extend it with disease as well. And what we're going to do here, we also have these different techniques, compare, and just to, be, consistent between with before, we use the Bonferroni as well. Bonferroni. And then, of course, we want the effects in here as well. You can always check the help file for the PV command to see what all these things are. And there are many, many other things you can do here still. And the same with ANOVA command. We can also do higher way ANOVA. We can do repeated measures and so forth. You may want to check that in a different video, but for now, we just stick with the two-way ANOVA. So if I do this here, hopefully I didn't write it wrong, then we should get with all kinds of different groupings here. Actually, you see I scroll over a lot of groups here. And we're going to get, if I'm not mistaken, 66 groups indeed, because these are all the different ways you can segment it. Group 1, 2 in drug versus group 1 with disease. So you can do all these cross combinatorics or all these different things. Whether this is the right way to do it or not, I'll leave that to you. But here you can see which of the exact combinations are significant. For instance, this one, 1, 1, 3, 3. Just to give you an idea. Whether it makes sense, all this stuff, leave it to you. But in any case, this is exactly how you would do a two-way ANOVA, also how you do the shorthand notation, so a fully factored one as well. And of course, you can also do this PV mean to test the difference where they actually come from. And that is all what I have for you today. I hope you learned something in this class in Stefan's Classroom. I hope to see you back for another class in Stefan's Classroom. Have a good one. Bye-bye.